Our next example is HCN, and this is going to give us a chance to look at something called multiple bonds. When we say multiple bonds, we're talking about double bonds and triple bonds. Double bonds are represented by a double dash. That's going to represent two pairs of shared electrons, and then you're also going to have triple bonds, which are represented by a triple dash. Okay, and of course you're going to have atoms on each side of these, so you might have maybe a carbon-to-carbon triple bond or a carbon-to-carbon double bond, where that just represents additional electrons being shared. These are stronger bonds, they're tighter bonds, they're closer. They don't occur as often, and the reason for that is atoms don't want to share their electrons unless they just have to, if that's the only way they can achieve an octet. We're still going to follow the steps, it's just that this time we're actually going to get to step 5. Last time we were done at step 4. Okay, step 1 is the same. It says you're going to add up your valence electrons. Hydrogen has 1 valence electron, carbon has 4, it's in group 14, and then nitrogen's in group 15, so it has 5 valence electrons. So our total number of valence electrons is 10. We're also going to put the least electronegative element in the middle. The thing is, hydrogen can never go in the middle. Hydrogen will never have anything on it besides just one single bond. It can't have a lone pair, it can't do double bonding, so it's impossible for hydrogen to go in the middle. So therefore, our least electronegative element is carbon, and we'll put it in the order just like it appears there. Connect them at first with single bonds. That represents 4 electrons. So we just used up 4 electrons. Each of those bonds was 2. So now we've got 6 electrons left. Now we're on step 3. It says fill the octets of the outer atoms. Well, the outer atoms in this case are hydrogen and nitrogen. Only nitrogen needs electrons. Hydrogen will never have anything more than just that single bond, because remember, hydrogen's in the first energy level. It can only hold 2 electrons, and that's what the bond represents. Well, the 6 that we put on nitrogen, all right, that uses up all of our remaining electrons. We've got 0 left. So it would appear that we were done. We finished step 3, and step 4 says to fill the octet of the central atom, but we're out of electrons. We don't have any left. So what you have to do is you have to figure out some other way that everything can get an octet. Nitrogen's going to have to share some of its electrons. So you take electrons from the outside atom and you erase them and you turn them into a double bond. That makes things better. You see, nitrogen still feels like it has an octet because it's got 4 of its own, plus it's sharing another 4. Things are a little bit better for carbon because carbon has 4 electrons on the right-hand side and then 2 electrons on the left-hand side, so at least carbon feels like it has 6, but we wanted to give it 8. So we're going to have to share some more electrons. We're going to take another couple of electrons from nitrogen, maybe those 2 this time. It doesn't matter which 2. We'll pick those 2. We're going to erase them. And we're going to turn those into the third part of a triple bond. And by doing that, nitrogen still feels like it has a total of 8 electrons. It doesn't want to share all these electrons, but it's the only way for carbon to get an octet. So nitrogen has 6 on the left in the form of the triple bond, and then it's got 2 of its own on the right. So nitrogen is satisfied with an octet as shown there. Carbon is also okay because now carbon has 6 on the right-hand side and 2 electrons shared with hydrogen on the left-hand side. So in that way, carbon also has an octet. Hydrogen is fine because hydrogen only wants a single bond. All right, so there's our final answer on this one. HCN with a triple bond. So you only have to worry about a double and triple bond when you get down to 0 electrons, but not everything has an octet. Then you just have to erase a pair from the outside atom and turn them into a double bond. And if that doesn't work, then take another pair and turn it into a triple bond.